In the first problem, we're solving 2,105 divided by 5. So last year when you worked on partial quotients, you thought about it as how many times can 5 go into 2,105? And a lot of times we would write our guess on the side. So you would say, I know that 5 times 400 would be 2,000 and subtract. So now really, you're not doing anything different than what you did last year with the new version of partial quotients. The only difference is you're lining your place values up on top. You're saying 5 can go into 2,105 400 times, and now you're writing it on top, lining up your place values so that your 4 is over the 1 because those are both in the hundreds place, and then still writing your 2,000 underneath, and then you would just subtract. It's still going to give you the same exact answer so that you're left with 105. So then, just like with partial quotients last year, it's the same exact strategy. You're saying how many times can 5 fit into the 105? So we could take a guess of 20 because 20 times 5 is 100. So here we put the 20 there, but with this version of partial quotients, we're going to stack the 20 on top so that the 2 is in our tens place and the 0 is in our ones place. But either way, we're still taking out a group of 100. Which gives us 5 ones left over. So then I'm saying how many times can 5 fit into 5, and that would be 1 time. Same thing, I'm just writing my 1 in my ones place with partial quotients over here so that my place values are very easily lined up, because oftentimes when we did partial quotients this way, some people would get our place values confused. And then I would take out that one group of 5, which is 5, because 5 times 1 is 5, and still be left with nothing. So when you add it up, it's very easy to see that my answer is going to be the 421 because the place values are all lined up. I'm going to get the same answer here. It's just a different way of writing it. The benefit of writing partial quotients in this way over here is that your place values are guaranteed to line up because you're lining them up with the place values of the original number. So when you have to find a different way to divide 2,105 by 5, you can start with any other number. So for example, originally we started with 400 times, but we could also start with saying 5 times 200, which would give us 1,000. So I'm saying 5 times 200 would take out 1,000. And then I would subtract. And I'm left with 1,105, which shows me I could do another 200 groups of 5. So I'm going to write another 200 up here. Then 5 times 200 would give me the 1,000. Now I'm left with 105. So now I have to say how many times do I think 5 could fit into the 105? So I'm going to go with 20 because I know that 5 times 2 is 10, so 5 times 20 is 100. And just like last time, I'm left with 5, so I'm going to say 5 times 1 would give me 5, so I could subtract out that 5. And then looking up here with my partial quotients, I'm going to add up. So the 2 plus 2 would give me my 4, because there's 2 and a 2 in the hundreds place, so 400, a 2 in the tens place, and a 1 in the ones place for an answer of 421. And if I wanted to check my work, I would say 421, so my quotient, my answer, times 5 to make sure that 5 groups of 421 would actually give me 2,105. So 5 times 1 is 5. 5 times 2 is 10. So put down my 0 and bring up my 1. And 5 times 4 is 20 plus that 1 would be 2,105. So then I know I got it right.